actually hadn't quite formulated my thought when I raised my hand.
Okay, so it cannot possibly be she walked 8 miles out. I mean, she ran 8 miles out and walked 2 miles back, because the problem says she gets all the way back to where she started. Does that make sense? So this is what led you to say, maybe she ran for, let's say, a half hour. Okay?
That means she's 4 miles out.
If she ran for a half hour, she made it 4 miles out because she was going 8 miles an hour. And then, how long did she walk back?
For 1.5 hours.
1.5 hours, because you know she was gone for a total of 2 hours. And 1.5 hours, she was walking 2 miles an hour? Did she make it back?
No.
No, because she only made it back 3 miles, right?
She's close.
Would it be 15 minutes running and an hour and 45 minutes walking back?
Let's try it. 15 minutes. That's a quarter of an hour, right? So that means she made it 2 miles, right? Because she was running very fast. Can you run 8 miles an hour?
No.
Can you
Like
run?
me?
I can't. People can.
Not for long distance, but I mean, yeah, sure I can.
All of a sudden, I'm looking at
But not for a
really?
long,
She
like
runs 16 miles.
a marathon. I can't do that.
Okay. So this very fast person ran for 15 minutes, 8 miles an hour, made it 2 miles, right? Because that's a quarter of an hour. So 2 miles. And then came back for 1.75 hours, 1 3/4 hours. The rest, does that make sense? You could write it as 1 3/4. You could run it as, go ahead.
15 minutes is too small. She would have made it and then some.
And then she would have been too far, because if she walked this far, she's walking something like 2, 3.5 miles or something like that. Okay, now hang on for a second. Before we guess any more numbers, what we're doing, you could figure it out from here. What you're doing is an actual method called guess and check. And this is an actual, people do this for different problems, and it has, in fact, in some contexts, this method is called Newton's method, after the Newton, Isaac Newton, because he used this method when he was doing stuff in calculus. Okay, so it's not cheating to do this, but it's also not algebra, right? So we're smarter than this. So let's try to generalize this. What are we doing when we're figuring this out? What we're doing is saying, well, she ran for some amount of time, right? There's an unknown. What you guys keep giving me is a time that she ran. 15 minutes, half an hour, 1 hour, right? So let's just say she ran for X hours.
We're writing it as an equation now.
And now we're going to write it as an equation. So now I think I understand the problem. My plan is to call X the number of hours that she ran and formulate an equation for this. So far, so good? So what does the equation do? What am I doing when I was doing these calculations? Something had to be equal, right? This one was too long. She got all the way back. The one up above was too short. She didn't make it all the way back. My goal was to get her back to her starting place, right? In other words, the distance that she travels out should be the same as the distance she travels in.
She ran for 18 minutes.
Don't know. Let's solve the equation. Let's not guess and check anymore. Did you solve an algebra? You're just shooting in the dark. Did you solve an equation, or did you just make a guess? You just made a guess. Okay. You can guess. Eventually, there's a possibility you'll get it.
It has to be between 1 and 120 minutes.
It's a number between 0 and 120. Okay. So let's formulate the algebraic equation. The observation that I'm making is that by these sorts of weird schematic drawings that I was using, was that there's a distance that has to be the same. The distance out has to be the distance back because she got back home or to the starting point or whatever. So how do you figure out if she ran for X number of hours, how far out did she get?
The whole race is
But how far out did she get? If she ran 15 minutes, she got out 2 miles. If she ran a half hour, she got out 4 miles. If she ran 1 hour, she got out 8 miles. If she runs X hours, how many miles does she get out?
X hours. Or Y hours.
Distance equals rate times time. Distance equals rate times time. We know the rate.
X equals 8x.
8x is how far she ran. 8x is how far she ran. She ran 8 miles an hour for X numbers of hours. That's how far she gets. So far, so good?
And 8x.
And to get back, it has to be the same as, now, okay, think for a second. Where did the 1.75 come from? Where did the 1.5 come from? Where did the 1 come from? She's walking for so this is the distance. This is the distance out. The distance back is a rate. Okay, we know what the rate is. She was walking back at 2 miles an hour. But what we don't quite know is the time. How long was she walking back? Could call it T. I'm going to think about it. You actually can figure it out from the information.